So welcome to Pinoy Math-Tinik. So our next topic is all about elimination of arbitrary constants. So this is arbitrary constants is a way to generate differential equation from an equation that expresses relation of variables and coefficients. Also, take note that the number of derivatives produced must be equal to the number of arbitrary constants. So let's try on our first example. So we have y is equals to c1 cosine 2x plus c2 sine 2x. So we can see, um, we'll change my ink first. Then, as you can see, we have two arbitrary constant, which is c1 and then c2. So it means to say that we have to take two derivatives. So now let's take the derivative, the first derivative. So y prime is equal to c1, and then the derivative of cosine 2x, which is negative sine 2x, multiply by the derivative of inside. So it's chain rule. So the derivative of inside is times 2 plus c2 multiply by derivative of sine 2x, which is cosine 2x, and then the derivative of 2x, which is equivalent to 2, 2. And then simplifying further, so we will have negative 2c1 sine 2x plus 2c2 cosine 2x. We'll take note that, um, change my ink first to blue. So this is our equation 1. This is our equation 1. This will become our equation 2. So and then change my ink. So let's now take the third derivative, second derivative rather. So the second derivative, y double prime is equal to negative 2c1 multiplied by derivative of sine 2x, which is equivalent to cosine 2x, multiply by derivative of the inside, so which is 2 plus 2c2, apologies. So multiply by plus 2 multiplied by c2 multiplied by the derivative of cosine 2x, which is equivalent to negative sine 2x multiplied by the derivative of either side, which is equivalent to 2. So further simplifying our equation, we will have negative 4c1 cosine 2x plus, sorry, it should be minus 4c2 sine 2x. So it is going to be our equation. It's going to be our equation number 3. So this will become equation number 3. So as you can see, when we use equation 1 and equation 2, we could eliminate C1 and C2. So let's try it. So now we have y is equal to C1 cosine 2x plus C2 sine 2x. Then the other one is equation number 3. So which is equivalent to y double prime is equal to negative 4 c1 cosine 2x minus 4 c2 sine 2x. So you can see, if we multiply the first equation by by a factor of 4, we will have we will have this. We'll have 4y is equal to 4c1 cosine 2x plus 4c2 sine 2x. And then we have the other one, which is y double prime is equal to negative 4 c1 cosine 2x minus 4 c2 sine 2x. As you can see, when we add the both equation, we will have y double prime plus 4y, and then negative 4c1 cosine 2x plus 4c1 cosine 2x, that's cancel out. Then the other one is negative 4c2 sine 2x, then 4c2 sine 2x, it will also cancels out. So we will arrive is equal to 0. So that's the answer. Now let's go to our second problem. So our second problem is x cubed minus 3x squared y is equal to c. As you can see in our second problem, we should only take the first derivative to eliminate our arbitrary constant. We only have one arbitrary constant, which is this one. So now let's take the derivative. So we will have 3x squared minus the derivative of this. The derivative of that, we will use quotient rule. So take note that quotient rule is equivalent to v du plus u dv. So we will take this one and then take the derivative of this one using quotient rule. So now let's go. Then we will have the derivative of 3x squared, which is equivalent to 6x multiplied by y plus, and then copy the 3x squared multiplied by the derivative of y, which is equivalent to y prime. Quantity is equal to 0. Now we will have, as you can see, all all of the terms are divisible by 3, so we can multiply all of it by 1 over 3. So we will have x squared minus quantity of 2xy plus x squared y prime is equal to 0. As you can see, it also divisible by x, the whole equation for first, and then we will multiply it by 1 over x. 1 over x. So we will have x minus 2y, quantity, 2y plus x times y prime is equal to 0. Further simplifying our equation, we will have x minus 2y minus, distribute the negative, so we will have minus xy prime is equal to 0. As you can see, y prime is equivalent to dy over dx. So I'll change our y prime with dy over dx. So we will have this x minus 2y minus x, and then I'll change y prime into dy over dx. So we will have multiplied by dy over dx equal to 0. And then I'll multiply both sides by dx. So we will have x dx minus 2y dx minus x dy equal to 0. Simplifying further, we will have x minus 2y quantity dx minus x dy is equal to 0. So that's our final answer. Now let's go to our example number 3. So we are given that y is equals to cx plus c squared plus 1. So in here, as you can see, we have only unique one arbitrary constant. So we will only take the first derivative. So we will have y prime is equal to the derivative of cx, which is equivalent to c, plus the derivative of c squared, which is constant, so that will become 0, plus the derivative of 1, which is also equivalent to 0. And then we will have y prime is equal to 0. Take note, we have to eliminate our arbitrary constant. So we should substitute y prime into our c, or into our arbitrary constant. So we will have y, by substituting, we will have y is equal to our c is equivalent to y prime multiplied by x, plus our c is equals also to y prime raised to the power of 2 plus 1. So that's the answer. Now let's go to our last example. We have the most complicated of all our examples. So we are given that y is equals to c1 plus c2 e raised to 3x. So as you can see, we have two distinct arbitrary constant, c1 and then c2. So I'll just change my ink. So in here, we will now take the first derivative. So we will have y prime. So apologies. What's happening?